everybody, this is Great Math number 34, and today we are going to do, just like I said in the last video, you're going to know the area of how to do a circle. Yeah, that might be hard now, but in math that's really basic, so let's get it so it does be basic for you and not be complicated, okay? So we're going to start off with a little one. I'm going to start off with a little, oh, whoops, no, I'm not supposed to write that. Okay, it says two quarter circles are drawn in a rectangle shown. Let me draw that rectangle. Okay. Two quarter circles meet at the point on a side of the rectangle. If the radius of each quarter circle is 6, then what is the area of the shaded region? Okay, so for those who don't know what a radius is, let me explain on this board. The diameter is the entire length to here. That's the diameter. The radius is only halfway from the center to here. The circumference is the entire thing. To get pi, every circle, if you divide the circumference by the diameter, you get pi. So let's move on. Sorry. Okay, so since the diameter is 6, and since the diameter is 6, that means these are the centers of the circle. Okay. Okay, since we know to find the area of the circle, we have this formula. And this formula right here. Pi r squared. Remember, it's not pi r, the entire thing squared. I got that mixed up. It's just this. Pi times r squared. The radius is 6. So it's going to be pi times 6 squared. 6 squared is 36. So we get 36 pi. Now, it's only for a quarter, so we have to divide that by 4. Then we'll get 9 pi. Now, you're asking, how come we can't just turn pi into 3.14 and just get it over with? Well, only if it asks you to estimate, that is when we do it. But for now, we're just going to put pi as if it's a variable. But on our solution, it might say what pi is equal to, which pretty much it won't, because the variable here, you're not trying to find it, it's just with it. But you know what it is, right? 3.14, yeah. So let's get moving. So it will be 9 pi. It will be 9 pi. Since there's 2, so each one will be 9 pi. Okay. And now, what can we do now? It says, what is a shaded area? Well, we can find the entire area of the entire thing subtracted from these two guys, and that's what we'll get there. But then what is the area of the entire thing? Oh, since they meet at this point, so that will be 6 and that will be 6. When you add them together, you will get 12. Ta-da! Done. So that means the area of the entire thing is 72. Okay. So it will be 72 minus 9 pi plus 9 pi. It's 18 pi. That's our answer. Yeah, that's our answer. Just that. 72 minus 18 pi. Oh, wait. Wait a second. Yeah, 72 minus 18 pi. That's our answer. But why? It's not one number. It's two numbers different subtracting by each other. No, it's just, that's our answer because we can't calculate. Because then we would have to able to know, just to make it one number, we'd have to know what pi is from the beginning to the end, but we don't know that. So if you did like this video on, oh wait, we're not done yet. We have one more problem to do. I told you that's only a warm-up. Let's actually do the real one. This one, it does require this part. Let's get to it. So first, let's draw it. You know, these half circles look weird. In the figure shown, points D, E, and F are midpoints of semicircles ADB, BEC, and DFE, respectively. If the radius of each semicircle is 1, meaning that the area are the same, then what is the area of the shaded region? You notice something here? Well, maybe it'll be easier if I did this, so we only have to do quarter circles. This is the exact same thing, but you flip it. Now remember, it doesn't mean it's the exact formula, but yeah, it's the same thing. So the radius of each semicircle is 1. So that means, this is 1. 1 plus 1, that's 2. That's 1, and that's 1. Okay, so we'll do the same way. 1 times 2. 1 times 2, that's 2. So the area of this thing is 2. But then we have to subtract it by these guys. Well, 1 times pi is pi. So to find it, okay, so pi r squared. Pi times 1 squared, that's just pi times 1, it's just pi. And we have to divide it by 4, which we'll get pi and 1/4. Okay, so since there's 2, it'll be 2 minus pi 1/2. Okay, but then we'll have to add it by this guy. So that's 1/4 plus 1/4, that's 1/2. So our formula would be this plus pi and 1/2. But wait, since you have these two together, what you can do is you can cancel them out, meaning the answer is 2. Why can you cancel it out? It's negative pi and 1/2 plus pi and 1/2. As do those together, you get 0. That's just 2 then. And ta-da, that's your answer. Wait, do you notice something? Since these have the same area as this, doesn't that mean that we could have just taken these guys and put them here, and we just find the area of this entire box and that was done? We could have done that. I'm not kidding, so 1 times 2 is 2. That's the area of the entire thing. Yeah. Yeah, so all the things you can discover if you can just figure out different ways. That was so much easier if we could just done that. Well, if you did like this video of Great Math number 34, please do subscribe and please give a big thumbs up to Great Math, especially for me, JP. And hope you like this video. And this is Great Math number 34 with me, JP, and I'll see you next time. Goodbye.